All right, stoichiometry lesson number 3. This is really not new information. But what I want to do is there is another method besides dimensional analysis to show you how to do these gram, mole, gram problems. So, quick review. The way the problems were before, your first step is you have to have a balanced equation. So, let's say that I gave you CaCl2, calcium chloride, plus sodium nitrate, which then breaks down to, the double replacement reaction to sodium chloride and calcium nitrate. So there's your given reaction, okay? I swear that's a 3 right there. It really is. Okay, that's your given reaction. Now I have to balance it. This one, I am happy to say, is ridiculously easy to balance. If you need practice balancing reactions, get it. Go online. Search for it. You need to be able to do it. But simply with those two coefficients, I'm balanced, I'm done, I'm good. So, the problem I'm going to give you is 16 grams of CaCl2, calcium chloride, is going to end up needing how many grams of sodium nitrate. So the way I showed you to do it in the last video was with big old dimensional analysis. You were doing gram, mole, gram. So we would start with my grams of calcium chloride down here, moles of calcium chloride up here, and we would convert that to moles by using the molar mass off the periodic table. So we would go to the periodic table, we would use the molar mass of calcium chloride, which is 110.9. Okay, you could make that 11, that's up to you. Remember our rules, you only round 0.9s and 0.0s. So 110.9, we'll keep it there. Then we're going to use moles of calcium chloride to get to moles of sodium nitrate. You can only have two different chemicals on top of each other if they're both in moles. So we go to the balanced equation. Coefficient in front of NaNO3 is 2. Coefficient in front of CaCl2 is 1. Then my last step, I'm going to go from moles to grams, moles of sodium nitrate to grams of sodium nitrate. And again, I'm going to use the molar mass from the periodic table, which is 85. So this was the way we set it up before. To calculate this, very simply, you multiply across the top. So 16 times 2 times 85. You hit enter in your calculator, divided by 110.9 times 1. That's pretty darn easy. And what we get is 24.53 grams of NaNO3. Great. Wonderful method. Gram, mole, gram. Again, the first two are my given, the second two are what I'm looking for. The only problem here is this dimensional analysis gets confusing for a lot of people. So I want to show you another technique for doing the exact same problem. The other technique uses a chart. To do the chart, you still have to have a balanced equation. That part does not change. So I still have to have my CaCl2 plus 2 NaNO3 yields 2 NaCl plus calcium nitrate. CaNO3 with a 2 outside that bracket. Have to have my balanced equation. But then what I'm going to do is I'm going to make a chart. Underneath each chemical, I want 3 things. The first thing I want is the mass. That's going to be in grams. The second thing I want is the molar mass. The third thing I want is the moles. For a gram, mole, gram problem, you are actually going to make a U on this chart. So the problem we looked at on the previous page was 16 grams of, let's try that again, of CaCl2 are going to end up making, making how many grams of NaNO3? That was the same problem we just did, exactly the same. So here's how it looks different. First thing you have to do with this method is look at where you're starting. I'm starting with 16 grams of CaCl2. I need to put that in my chart. So under CaCl2 and beside mass, I'm going to write a 16. It's under the chemical I want. It's beside what it actually is. Then I'm going to calculate. I'm going to go down first. Always go down first. And I'm going to find the molar mass of CaCl2. We did that before. We added up all the parts. It was 110.9. That was when we added up a calcium plus 2 chlorines. So now, in order to find the moles, I have to do math. Okay, both of these I was able to find just by, looking at the periodic table and looking at the problem. So what you need to remember is down, divide. D for down, D for divide. So to get my answer for moles, I'm going to take 16 divided by 110.9. Now, this is my number one piece of advice if you use this method. I'm going to round what I'm writing on this screen. I am not rounding what's in my calculator. I am leaving my calculator with all these little decimals. I'm simply not writing them down. That will give you more accurate answers rather than rounding every single time you do a calculation. So if you want to write them down, go right ahead, 0.14427412083. Have fun with that. So now I've gone down. My next step is I want to go over to the chemical I'm looking for. Well, in this problem, the chemical I'm looking for is NaNO3. That's right here. So I only need to go over one little spot. If I was going to one of these chemicals, I'd go all the way over to where they are. But in this one, we just have to go to there. So to go over, this is the hardest part, you have to multiply times the mole ratio. The mole ratio, you're going to take the coefficient of what you're going towards. Okay, I'm going towards this guy. And that goes on top. Then I'm going to take the coefficient of what I'm leaving and put it on the bottom. Remember, what you want goes on top. Forget chemistry. Think about life. Your priorities, what you want, that better be at the top of your list. The stuff you're tired of, the stuff you don't need anymore, the stuff you don't want to deal with, that needs to be at the bottom. You need to step on it and leave it somewhere else. So what you're going towards goes on top. So I'm going to put this in my calculator. Again, I've left all the decimal places intact, but on here, I'm just going to write the first couple. Okay? In my calculator, it's still right. This number, this 0.289, came from doing this math of 144 times 2. Okay? So this is telling me how many moles of NaNO3 I've got. So I've gone down, I've gone over, now I'm going up. Okay, down was divide, over was multiply, up is also going to be multiply. So I've got to find the molar mass. Just like we did before on the last method, I add up Na, N, and 3 O's, and I get 85. And I'm going to take what's in my calculator to go up, 0.2885 blah, 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 times 85. And what do you know? I get 24.53. This is my answer. This is the mass. If I kind of track it over here, it's the mass of NaNO3, which is exactly what my problem was asking me for. This is called the chart method for doing these kind of problems. Okay? You are not doing dimensional analysis, but you do the exact same work. Look at this. 16 divided by 110.9. If I go back, this first step right here is 16 divided by 110.9. Look at the next step, okay? Times 2 over 1. If I go back to my other way, times 2 over 1. Then my last step was, let me change my color again, times 85. If I go back to my other way, times 85. These are the exact same problems, and truthfully, one is not more work than the other. They're very much equal. You just have to decide which one works for you. That's called the chart method. My advice, experiment with them. Try them both. See which one you actually like better. If you know you love dimensional analysis, it's usually a no-brainer. But if you're kind of on the fence, this takes a little practice. You're going to have to, that's supposed to be a star. You're going to have to try this a lot of times. Okay? It takes a little while to get good at it, but it's doable. Last thing I want to point out about this method, it doesn't just have to be a gram, mole, mole, gram problem. Okay, let me go do another. We're going to do a simple equation for this one. Let's do Na, in fact, let me move that over a little bit. Let me do Na plus Cl2, I know I always use this equation, yields NaCl. It's just easy. Step one, got to balance it. So this is a pretty happy, easy one to balance. Life is good. So now let's say the problem that you're given, and I'm going to write it down here at the bottom, and I'm kind of making this up as I go, is let's say you have 4.3 moles of sodium and you want to know how many moles of salt you're going to make with that. Or I'm sorry, forget moles. Let's not do moles. Let's do how many grams of sodium you're going to make with that. You can still do this with the chart method. My steps that I told you when you were doing dimensional analysis earlier were always going to be step 1 in balance, okay? And then I had said step 2, find your start and stop point. I'm going to switch that a little bit and say step 2 is pick your method. Are you going to do the chart or are you going to do dimensional analysis? One or the other. Now step 3 is going to be find your stopping point and starting point. That's what you do for every problem. When you were looking at gram, mole, mole, gram, we were drawing arrows. When you're doing the chart, you can actually fill it in basically in the chart. So if we look at this, I know I'm going to have my mass up here, that's in grams, my molar mass here, and my moles. That's what's in my chart. So if I look at my problem, 4.3 moles of sodium, I'm not starting right here. That would be mass of sodium. I've got to make sure I find the right starting point. So moles of sodium is going to start right there. My ending point is grams of NaCl. That's going to be up here. So in this problem, I'm not doing a U like I was before. I'm simply going to go over and then up. So if I look at this, let's try this one. I'm going to plug in my given, 4.3 moles. That's my given of Na. Now I'm going to go across. If you remember, to go across, you multiply. The only one dividing is going down. And I'm going to multiply times my mole ratio. I got to put what I want on the top and what I'm trying to leave on the bottom. Okay, what I want is on the top. What I want to get rid of is on the bottom. Do my math. This one's pretty easy because it's just times 1. Gives me 4.3. Now I'm going up. So I'm going to go to my periodic table, find the molar mass of sodium chloride, which if you have no life like I do, you know is 58.45. I know, it's sad. And I'm going to multiply that out. 4.3 times 58.45. When I do my little calculation here, this was a big one. That's what happens when I make up numbers. It tells me I would make 251.34 grams of sodium chloride. And that's my answer. Okay, so this is how you do this. This is how you do the chart method. It's an alternative method to dimensional analysis. They both work. They're both effective. You just have to find the one that's best for you.